Good morning, good afternoon, or good evening, depending upon where you live around the world. An idea came to me, and I, of course, had to do a quick sketch of it in SketchUp and then make a video of it. I had been alluding to the fact that should we be required to make dihedral angle cuts on the top of our struts to take rigid cladding, that we could lower the plate to clear the point where we'd have to angle these struts. Not knowing exactly what that would entail, I had a thought, well, no, hang on, that won't work. It won't allow us to fix the cladding all the way along over the metal anyway. I had thought about reducing the height to a maybe 2/3 the way down the depth of the strut, or halfway maybe, but that didn't suit me because I do like the idea of having two plates, one top and bottom, to equalize the rotational movement through the struts at the attachment with the hubs. Then I thought, hang on, it's only going to cantilever over the what we've got here, a fillet with the dihedral angles cut as required for each strut, and we could make any adaptation in height for the, as we know the struts themselves are, if we want the geometry to come to the perfect point at the center line, are at a different height relative to each other. This can be accommodated by the fillets. So we've covered two or three things: the dihedral angle cuts, the discrepancies if we keep the struts at the right height, or sorry, I'll back that one off. We'll distort the dome somewhat for ease of construction and bring the struts up to a common height, which is the plate itself, and the discrepancies that we have then introduced we can neutralize if it's required by the way of fillets. And the fillets can run over the plates, they don't need to be fixed through, although they could be, and therefore they only cantilever themselves out the amount of the plate, which is approximately 200 millimeters. Now that's not a huge amount, and if we want to, we could still fix through the fillet into the plate. After all, it's only going to be between 3 and 6 millimeters. So we could put a pilot hole through and create a thread. Wouldn't be too hard, and we could put a machine screw, or with a good quality construction adhesive sealant, we could put dobs of it underneath the fillet onto the steel. Therefore our cladding would be able to be installed flush on the surface. Now if we wanted to make these wider than the struts or slightly narrow, you wouldn't want it narrower if you were going to be putting rigid cladding on, but we've got a bit of fudge factor there, so it wouldn't be too hard to think that this is an option for being able to put rigid cladding on where we may not have originally designed the structure to take rigid cladding. Now, would it look aesthetically pleasing? Done well, I can't see any reason why not. There may be benefit to this that I haven't considered yet, but thinking about it, it would be a lot easier to add fillets like this than it would be perhaps to angle the struts themselves. I'll have to mull that over. I think at this stage that is a way forward, because to be fair, I doubt that I'd be covering much of the dome in rigid cladding, but we've now got a workaround to achieve that. That might be a good idea. Okay, that was a quickie, wasn't it? One of the shorter ones for me, but if we cover off some of the bases, we can move forward without having to unduly burden ourselves with the what if in this situation scenarios. So we've covered it: dihedral angle, rigid cladding, fixed over the plate, if necessary. Okay, that's it. Short and sweet. See you later. Bye.